Welcome to our class today. We want to continue with our study on how to write circuits in Noir. So today we'll be looking at arrays in Noir and how to use them. The first thing we need to know is what an array is. That is where we begin from. Its definition, then how to write them. So an array is a way to store a fixed number of values of the same type. So this one, you are storing them together. So they must be of the same type. That is the underlying thing. That what you are storing must be of the same type. Now, so how do you declare such arrays? Now, just the same way we do, you can see that the X here is a private, is a field, and then a private field. There's no word pub before it. And this is also private. There's no problem there. They can also be public. There's no problem. But how to declare array? This is an example. Let my array be this. So you can see X and Y, which are both fields, have been stored together. And let your array be. Now, this is an array comprising of two things, two field elements, X and Y. So this is your array, and this is my array. Now, the thing is, we are storing things of the same type together. So you can see in this case, we've stored together elements of the field and so on. Now, so that is an array. That is an array. Say, let my array be that, and so forth. So we'll be looking at several examples. This is just an example to start us off. Now, the explanation to the above code, my array is an array with the two elements, X and Y. Of course, they must be the same type. And your array is the same, but the only difference is that your array, the elements are of the field, elements of the field. So both arrays are correct. They have stored elements of the same type together, and that is the most important thing. That the elements of the same type will be stored together, and that is what an array does. Now, so having looked at that example, I want us to look at how do we assess access elements of the array. Now, so you've written your you write your circuit, and you want to get a certain element from the array. That is what this means. How do you get that element of the array? So I remember that before you get the elements of the array, remember that an array is arranged in you identify the position of the array using the index. And the first element here is index 0, index 1, 2, 3, 4, and so on. So if you want to find an element in index 0, you would say let first element A, then in bracket, the square bracket 0. So it means you want to find an element in that position. If you want to find an element in position 2, that is index 1. If you want to find element in which index is this? 0, 1, 2, 3, 4. This is index 4. So you would say let fourth not fourth, there's a fifth. Let the fifth be a 4. So that means you're finding an element in the fifth position, index 4. So the first index is 0, then 1, 2, 3, and 4, and so on. So that's how you identify. So if you write that way, then the code knows that is the element you want to find. So you can find those elements and then print. You can want to print an element in index 5, an element in index 4, and so on. So that's how we find elements of an array. So I've explained and I've said A with bracket 0, this means gets the element, the first value, the first value element. So that is this element. And then gets the second value. This is the element 2. And then, so the indexing begins at 0. So this is index 0, index 1, index 2, and so on. So it's the numbering of the index and how it begins from 0 going up. Now, so I'll now begin by showing some practical. I suggest a small practical. Of course, I'll now share my VS code. We do this practically, but look what the code, what it says. This is our array, comprised of elements 1, 2, 3, 4, 5, 10, 23. But again, this is index 0, index 1, 2, 3, 4, 5, 6. So if I say let first, the element in index 0, I expect it to print for me 1. And then the second element in index 1, it will print for me 2. And then the sixth element should be in index 5, 0, 1, 2, 3, 4, 5. I expect to print 10. And then this other element is in index 6, 23. But how it prints hexadecimal numbers. Prints hexadecimal numbers. So it's not going to print 10, for instance. I expect to see 10 is A in hexadecimal. Remember, hexadecimal use numbers 1, 2, up to 9, then A, B, C, up to F. So 23 will not be 23, but it will convert 23 into hexadecimal. And you remember how we convert numbers to hexadecimal. 23, you then divide by 16 to convert to hexadecimal. And you note the remainder in this case, if 16 were to go here into 23, the remainder will be 7. It goes there once. And then if 16 were to go into 1, go there 0 times, and the remainder will be 1. So then this number becomes 17. Now, so I wanted to print. You see, I've given it I've given it command to print the first value. So it will write the word first value. Print first value. So it will write the word first value, then print first. So it will print for me the first number here, which is 1. Then print second value. It will say second value, then write the second value, the number in the second position. And then print sixth value. So it will write the word sixth value, and then give me the number that appears in the sixth position. That is a command I've given it. So I just want to share the code and we see it doing that before we move ahead. If we remember that it's going to print these numbers in hexadecimal and not in as decimal numbers. Okay, so here is my code. The same command we've been looking at is here, the same code that we've been looking at is here. Just to share with you a few things. I've given it the provatomil, but this one you should not even worry about it because it will give it can write it itself, can write it. Don't need to worry yourself about it. But now we have this nagotomil. Not much what we've been looking at, the same thing. This target I can delete it because it's auto generated. We shall generate it again. So I can just delete it. But our main is here. And our main, I've even given it tests. I've given tests, but we shall come to that. The only thing I'm interested with is this part. So let's do nago compile. Nago compile. This is not necessary at this point, but I just want to generate our target when I do that. Nago compile. You can see our target back. Our target is here. Okay, but what is important, because we're supposed to do nago execute, but before that we need, I decided that we don't, this provatomil should not give you a problem. You can delete it and it auto-generate. I just want to show you that you can auto-generate it. I've deleted, so if you want to auto-generate it, I will say nago check. And that gives me my nagotomil, no, provatomil. Oh, this time it's not there, but the word has come. So it's just us now to put what is supposed to be put inside. In some cases, it will give you, and then leaves for you positions to just fill in some cases. Now, so once we have the provatomil, then we will do nago execute. And this is what will print what we just asked to print. And it has done that. It has given us the first element, which is 1. Let me just share, yes. The first element was 1. But as I said, it writes in hexadecimal. So that number is 0, 1. The second element is 2 in hexadecimal. Is that? And then on the fifth element, no, the element in, this element in the 6th position. The element in the 6th position, 0, 1, 2, 3, 4, 5. This is 10. So in hexadecimal, that element is A. So it's 0A. And then the element in the index 6, that is the element in the 7th position. And that element, I shown you that it would be 17. Because 23, you now convert that to hexadecimal, and we did that earlier. And of course, I've already shown you that you divide by 16, noting the remainder at every point and writing those values from the bottom going up. Now, so it has printed those numbers. So that is how we access them and then check. You can even want to ask it to print an element. Which one haven't we asked? So you must define it here, what you want to print. You must define here. So supposing I want to print an element that I had not printed, an element in the 7th. Now we do not have an element in the 7th position. If I do that, it will bring an error. No, we don't have, if I write 7 here, that would mean an element in the 8th position. 0, 1, 2, 3, 4, 5, 6. And the 7th element, the element in the 8th position is not there. So let me just ask it to write for me the element in the 4th position. Element in the 4th position, that is A3. Because this is the first position, second, third, then the 4th position is here. But to be consistent, this is what we are writing is the index. What we are writing is the index, and we begin with the index is 0, and then 1, then 2, and then 3. So I expect to write for me 4, but now let me ask it to write. Let me ask that I want that element in the 4th position. So I just write here 4th. I want to be consistent. And then also write here 4th. Okay, so let us do Nago execute and see what it says. Nago execute. Don't find 4th. Oh, yes, yes. It says it cannot find 4th in that, cannot find 4th. Okay, let me just share what is it. I'm looking at the cause of that, and I've seen we had not defined the 4th element here. We did not define the 4th element, so let's just define it. The 4th element is when index 3. No, not index 3. How come we had said 7th? Oh, we have repeated things here. We have repeated. So this was 1st, 2nd. This should be the 6th, the 7th. And then this should be this was to be the 4th. That was to be the 4th. So I put it there and then forgot to change the name. So that's why I'm wondering why it's not seeing it. So let's again do it. Now go execute. Yes, it has now done it. The fourth value, the fourth element is here. It says is 4. Let's just see. 0, 1, 2, 3, and that is correct. That is the element. So we can even change to 53 and sort it right. So it has to convert this 53 to hexadecimal. Has to convert it to hexadecimal. So now go execute. It has given us the fourth element down here as 35. So when you convert to hexadecimal, 53 to hexadecimal, that's what we get. Because you're dividing by 16 and noting the remainder at every stage. Good. So that is how we have seen how to access or get the elements from that code, and so it's now clear what you're supposed to do. It's now very clear. So we added a prover.toml, and we saw how to do that, and then the output came out. The first element is 0, 1. The second element is 0, 2. And I've already said that it's outputting in hexadecimal, not as a decimal number, but in hexadecimal. Now you may want to do tests. You may want to test. Testing ensures that your program is accurate, that it runs as expected. So you want to run tests. So let me just let us run tests, and I want to share again the VS Code. I had already included tests. So our tests are already there. So the first test is here. This one will pass. Just as I ask it to find, let first element be that, the second element be this, the sixth element be this, the seventh element be this, and now assert. You assert after you define, you now assert. You're giving the exact value printed. So I expect that the first element is 1. Just checking here. The first element is 1. I expect the second element to be 2. I expect the sixth element to be 10. And I'm also expecting the seventh element to be 23. So let me remove these other tests so that we test that. So I want to remove these other tests first. So let us test this. It's just Nago test. And the test, it was only one test and it has passed. Suppose you gave it a wrong seventh element, can it discover? Let's give it 22 instead of 23. Nago test. And it's telling us that no, that is 23 is not that element. Says the test, running test function, testing the array, fail to solve the program, cannot satisfy the constraint. The seventh element, it's in fact telling me the seventh element cannot be 22. Cannot be 22. So it highlights where the problem is. So when you change that problem, Let's create another problem. Let's create here again. Let's put the 3 instead of 1 and say Nago test. Again, it does not. Now it gives us 2 problems. It says fail. Okay, it has given us the first problem as the second element being 2. So when you correct that and do Nago test, it again will give you another problem where it is. Until you correct all the problems, it will then run. So when you correct that, you correct this, then you expect it to now run. Nago test. Now, so this is a test that is expected to pass. So that's how you write it. And then I've also another test here. And this test is also expected to pass. We have this element and it's saying, let X be the first element. Let X be the first element. The element in index is 0. Then you assert what X is. You tell us what X is. So I'm just showing you different ways of writing this. Because here you say, let the 7th element be this. Then you will come and assert, tell us what the 7th is. That's why I'm saying here, let X be the first element. The element in index is 0. You assert, now tell us what it is. It has to confirm. So it confirms for us. So let me remove this other test and then we run those 2 tests and see. Nago test. So it has run 2 tests and they have all passed. Let me add a test that is expected to fail. So this test is expected to fail. So look at how it's written. Test, then in brackets, should fail. Now, so the array is here. And we are told that let X be the second element. Let X be the second element. But now you've said that second element is 99. So we expect to fail. But now, since you've written it here, since you've written this way, we don't expect it to not to compile. It will compile because you've already said it will fail. You've already said it should fail. So that means when this one fails, then it has passed. So let's see. It means you've said what is correct. Now go test. So you ran 3 tests and they all passed. This one also passed because you had said it's a failing test. It's not correct. You had said it's not correct. So therefore, you have got it correct. You've gotten it correct when you say it will. When you say it will not pass. But if you give it the correct one, let us see, this element is the second element 2. So when you give it 2 here, when you give it 2 like that, and say Nago test, it must now do not compile. You can see it has said that the array running 3 tests, but one of them has caused a failure. One of them has caused the failure. And the one that has caused the failure is the one that is supposed to fail. The one that is supposed to fail, this one, is the one that has caused the problem. So let me just again run it, that you see what it is. So Nago test. Yes, you see the problem is you said it should fail, then you give it the correct value. You said it should fail, then you give it. When you say it should fail, you should give it so that it fails. and then it compiles as you want. But now if you want it to pass, let's remove this bracket. Should fail bracket. Let's remove that. And then just say the same thing. Let's say nago test. You see it has run successfully. 3 tests have run and they have all passed. Now, there's something I'm emphasizing there, how you write a test that is supposed to fail. That's how you must put in bracket should fail. Then after putting in the bracket should fail, then you give it a wrong value. So our return should fail. So if I put the correct value and then it will not run, then I'm supposed to give it a wrong value. So when you give it wrong value and run now, I've explained how you write a failing test and a passing test. And I've really emphasized that. So you need to know how to write it, how to write those tests as we move forward. Now, what about mutating arrays? How do we mutate the arrays? Note that by default, arrays are not are immutable. By default, they're immutable. So for you to mutate them, you must state it before. To mutate here, it means, for instance, you've said that, for instance, let me look at this example here. You can see here, for instance, first element, second element, third element, fourth, and then fifth. To mutate here means that you may want to change the second element to be a different element. You want to say, let the second element be 36. Now, the code sees very well that the second element is 2, but you want to change it to 36. So that means you must have said from the start that let this be mutable. You can see mute array. Let it be mutable. So it means if it's mutable, then you can change any of these elements to be another element. So you assert. So let's now assert and assert that the element in index 0 is 1. Then array 0 is 42. So we've mutated this one. We've made it different So we want the first element to be 42. So we mutated it. We've changed this element in index 0 from 1 to 42. Then assert that the element in index 0 is 42. So when you print this, it will run. It will run because you had already said that you want this array to be mutable. So it will. But if you had not included this mute from the very start, and you come here and assert that an element in index 0 is 42, it will reject because it's seeing the element in index 0 as 1. So it will not accept that. So for it to accept, you must have told it from the start that you want the array to be mutable. In other words, at any given point, you'll be changing the elements to any other element. So I've said in the explanation here, I've said that Noir enforces immutability by default. In other words, by default, Noir is immutable by default. It's immutable, and this is so because it's meant to avoid unintended side effects. So to avoid that, then it's immutable. So mute is required for in-place updates like assigning arrays. You want to take an array in index 0 to be 42, so that is what you want. So because of that, and I've said already that you must have included mute at the beginning. You should have done that at the beginning so that when you now say that you want the element in index 0 to be 42, then the program will accept. You can even assert that to confirm. You can assert that to confirm. Now, if you try to do it without mute here, you see here, there's no mute. There's no mute here, and you want to try and say mute, no, array 0 to be 99, it will reject. And the reason is we've already given that it's meant to be immutable. So the correct version will be that you have to include mute before you want to change any element to what you want. So I think I want to again share my VS Code so that we just see how that works, that you know that what we are saying is what is happening. Just want to share the VS Code, just a minute. Okay, so I need to first of all stop sharing that. Then now share this. Okay, so I've just changed the code, and this is my current code. You can see this one is let the array be this, and I've not included mute. So I just want to see if it will compile, and now go compile. Just want to see whether that will happen. It has not, because it says that the variable array must be mutable to be assigned to. So it must be mutable for you to assign this. You can see where it is putting, underlining this, that this, the number in index 0 can never be 99. So that is not possible. So for us to ensure that happens, we have to say mute. Say mute, and let's now try and see whether it will accept that the number in index 0 is 99. Now go compile, and now it accepts. Now it accepts this. You can even change and say the number in index what? This is index 0, 1, 2. Index is 0, 1, 2. So index 2, even say let the number in index 2 be 0. And again, when you do now go compile, supposed to accept. But you cannot go beyond that because you only have 3 elements there. So the last one is index 2. When you try index 4, it's supposed to reject. Let me see. And now go compile, because that means the element, the 5th element, and there's no 5th element. There's no 5th element. Assertion is always false. Error cannot assign to immutable variable. As a result, the compile circuit is ensured to fail. Other assertions may also fail during execution. Okay, so you see the elements are only 3, so the last index is supposed to be 2. The last index is supposed to be 2, not you cannot go beyond. Cannot go beyond. Okay, so you have seen how immutable by default Noir is. And so if you want to make it mutable, you have to define it. The word mute has to come from the very beginning so that you can now change any element, replace it by another element. Now this is just the explanation of that. Or after mutating, we can also print. You can ask it to print values now. And I've said changing values and observing effects. Arrays in Noir, like in Rust, are mutable if declared with mute. They're mutable if declared. But if not declared, they're immutable. So when mutable, that means after, if declared, when immutable, you can overwrite any existing element with any new value of the same type. Again, we had emphasized that from the beginning, that arrays, we are storing elements together and they must be of the same type. Now, so look at this example now. I've given, I've asked it to be mutable. I've asked it to be mutable. You can see that I've already asked it to be mutable. And I have 3 elements. And I'm assigning the first element to 99. Then I'm asking it to print the element in index 0 and give me the value. And then it's supposed to give me now 99. Then when I ask it to give me the element in index 2, just count index 0, 1, 2. I expect to give me 3. Because we've not changed that, the only thing we changed was the element in index 0. That is the only thing we changed. We did not change any other element. So it's only the element in index 0 that is given as 99. The rest of the elements remain as they are. So let's again just confirm that. I want to share again. Okay, so it's the same code I've been explaining. So let's, because we want to print, let's say Nago execute. We want to see, what are we printing? Is to print the element in index 0 value is 99. And element in x2 value is 3. That's what I wanted to print. So it has said index 0 value is 99. 63 is 99 is 63, because what it's just saying 16 into 99, how many times? So only write the remainder, 99 divided by 16, divided by 16. Let's just confirm that it's 63. Just confirm. It's not bad to learn. We're always learning. So I'm dividing 99 divided by 16, because there are 6 times. There are 6 times. The remainder is 3. In 3, and it went there 6 divides, and the remainder is 6. So you only write from the bottom going up with 63. So 99 in hexadecimal is 63. 63. So it's correct. It's correct to have said that index 0 value is 63. Now we also wanted to print index 2 value, and it's 3. Index 2 value is 3. If you want, you can add it to values. 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 And you can even want to again change another element here and say, you want to say let the element index 0, 1, 2, 3, 4. The element index 4, you want to call it even 16. Even 16, you want to call it 16. And you want it to print it. You just copy this and then we edit. Just copy this and then we edit. This time we will remember we are dealing with the element index 4. Index 4. And we expect it to print 0, 1, 2, 3, 0, 1, 2, 3, 4. Expect to print 7. Expect it to print 7. Okay. Expect to print 7. That's what? Not 7. We had changed it. We changed it to 16. We changed it to 16. So it will print 16. 16 in hexadecimal. So you divide by 16, and what is the remainder? That's how we get the value in hexadecimal. So now go execute. It has done it. Element index, good. That's the remainder. 10. Let me just show you. You could be wondering. Because it was 16, then divide by 16, it goes there once, the remainder is 0. Then what about that 1? How many times does 16 go into it? The quotient, that quotient, which is 1. 16 goes there 0 times and the remainder is 1. So then we have 1, 0. Writing from the bottom, the remainders from the bottom going up is 10. So that is the element in index 0. So you can see you can mutate, you can change. You change the element in index 0 and the element in index 4, but the element in the other indexes remain the same as they are. For instance, the element in index 2 is still 3. So those ones, they don't change. You only change the ones you mentioned under mutate. Okay, so I want to again share. Now, what about an array with the repeated values? Same values throughout. Same values throughout. How do you write it? So you want one that has zeros throughout, or ones, and so on. So you can quickly make an array where every element is the same this way. So let array field. So this is a field with 2 values, and you want it to be 0, 0, 0 up to 0, 32 zeros. So you want 32 zeros. So I said this slide introduces a concise way of creating an array with the same value repeated multiple times. Now you wanted 0, so 0 32 times. So this is how that array is written. This is how it's written. So you have field there, then 32. So field is the type of each element in the array. So those are scalars. So when you write field 32, you mean a fixed size array of 32 field elements. You mean you want 32 field elements. And when you write 0, 32, then this syntax means fill the array with value 0, repeated 32 times. So this is what you expect. This is what you expect. So you can again print. That's what I mean by accessing. You can again print the 5th element. Okay, there will be zeros all over. All of them, 32 of them would be zeros. So you may just want to print to confirm whether the 5th element is 32, whether the 7th element is 32 on a 0, whether the 7th element is 0, and so on. And of course, if you want, you can make it mutable so that you change a few values and the rest remain the same. So it's useful in initializing a buffer, creating uniform starting state, allocating space before updating values later. We'll printing, print first value, array in the index 0 position. Of course, it will be the first element, which will be 0, and then print last value, that is the element in the third position, that first position, and again, this element will be 0, because they are all zeros, that 2 of them. Now you can change specific elements, and I've already said that. We've already looked at this concept of mutating. So like here I say mute, array, although I want this array to be zeros, that two of them, but you can want to, when you write mute, you can want to change the sixth element. Change the sixth element, the element in index 5, you can call it 99. So when you print the element in index 5, what will come out will be 99. And this 99, of course, will be converted to hexadecimal. So what you'll be seeing will be an element in hexadecimal equivalent to 99. And if you print the element, the seventh element, of course, it will be 0. It will be 0. The fourth element will be 0. So the only that will change are the ones you will have defined here when you're doing your mutate. Mute. Then now after mute, you can change any element you want. And that concept, we've already looked at it in our previous slides. So you can just try it. You can try it. Now, so we also look at multi-dimensional arrays. So these are cases where now arrays were written as matrices. So arrays can contain other arrays, making a grid or a table of values. Now an example, let array be a field of 2 elements. So this is just a 2 by 2 matrix. 2 by 2 matrix. Now, so again, I'm just saying this slide introduces multidimensional array in Noir. Just like in other languages like Rust and C, Noir allows you to create arrays that contain other arrays. So when you write field with the 2 elements and 2, this declares that you're writing a 2 by 2 matrix. That is, in other words, an array with the 2 rows and the 2 columns. Or let's say an array with the 2 rows, and each of these 2 rows contain 2 field elements. Each of the 2 rows contain 2 elements. So this is a row. This is a row, and this row contains 2 field elements. 1, 2. And this is another row, and this row again contains 2 field elements. That's what I mean. So in other words, what I've formed is a matrix. I've formed a row of an element, let me call it A, and an element B, and an element C, and element D. So that's just a matrix. 2 rows, each of them 2 field elements. That's what it means. So I think that point is clear there. Now, so we've been talking about index. So the index for the first element is 0, 0. So when you say 0, 0, this accesses the first element in the first row. The first element in the first row. In other words, the top left element, the top left element. So when you're looking at this, the top left element is this. This is the top right element. This is the bottom left element, the bottom right element. So the top left element will be index 0, 0. So when I talk of index 0, 1, it's this element. The top right element. The first element here, okay, and then 0, 1, 0. It's only the index of this element. The index of this element is 1. In the first row, this is the second element, so its index is 1. Okay. So this one is just the right arrow. I was just trying to explain. I was saying row 0, row 0. So the first row is row 0, index 0. Has XY. Then row 1, this is row 1. The second row is row 1. So that is why I say this element here is, its index is 0, 0. Its index is 0, 0. This one, its index is 0, 1. And this one, its index is 1, 0. Because it's in row 1. But now in row 1, this is the first element. The index of this, it's in row 1, and it's the second element. So at your own time, you can copy this code in VS Code and run it. But the array is this, let the array, and I've already explained what 2, 2 means. These are two, an array of 2 rows and 2 columns. And we want it to have this and that. So using, what is the top left element? It's array, we've already said. And the bottom right element, the array, we've already said. So that is element 4. So you see what is this? This array is 1, 2, and then 3, 4. So just saying the bottom right element, its index is 1, 1. And that is 4. That's element 4 here. So the explanation is that this array has 2 rows with 2 columns, and the array 0, 0 would access the first top left element, and 1, 1 would access the last element in the bottom right. Now you can also, when you're doing, when you're trying that, try to print, and when you try to print, you're just telling it, once you understand those codes, those index, you can now print, because this array is just 10, is 10, 20, and then 30, 40. So you're telling it print top left, and you're giving it the position. The position is 0, 0. So 0, 0 is this element 10. So it's supposed to print 10. Of course, it will do that in hexadecimal. 0A, it will do that in hexadecimal. And then you're telling it print top right, top right. Top right is the element in row 0, the second element in row 0. So 20, of course, we'll be doing that in hexadecimal. So 20 divided by 16, it goes there once, the remainder is 4, and then into 1, it goes there 0, and the remainder is 1. So this is 1. What was this? This was 4. So it was 1, 4. So, and then bottom left, that one is in row 1 and column 0. It's in row 1, column 0. So we want also to mutate. Mutate works in everywhere there are arrays you can mutate. So that means you've already declared your rows and columns, but now you want to change specific elements in that row and specific elements in the column, for instance. So that you modify. So for instance, what we have here is, what we have here is 1, 2, and then 3, 4. That is the array we have. But you've said mute. That means you can change any of these elements. And you want to change so that the element in row 0, column 1, is the second element, which is supposed to be 2. You want it to be 20. So that when you print it, it will be in hexadecimal. It will be, I think, 14. Yes, in 14 there. And you also want the element in row 1, column 0, this element, which is supposed to be 3, you want it to be 30. So you are changing the elements according to your preference. So you use the word mute, and we've seen that from the beginning of our lesson. So we are now aware of what is supposed to happen. So you can see I've tried to change several elements there. I've tried to change. So you just copy this code and try to run it in VS Code and see what it prints. You ask it to print. And now use assert. Use assert so that you confirm whether it's correct. So I think next time we shall look at array methods, sort, map, fold, and so on. So that is what we'll look at next time. But today we looked at a number of things on arrays. It's good you try to do a lot of practice on them, do a lot of questions, try to write VS Code and see how it runs. And try to do so many things with their VS Code. At the bottom here, I've added some practice questions. I think I'll share a full list of my notes. Then you can try what you can do here. There's the activities here. This one says add up all the values in the array. So try and do that. This one says double each value in array. Try and do that. And this one says create and mutate an array. So you try to create and mutate. We've already looked at that and so on. So I'll share these notes, all of them, so that you try to do those hands-on activities just to as exercise. Thank you.